Here's an example of simplifying rational expressions. The first thing you want to do, you need to factor the top and factor the bottom separately. A common error is that students want to cancel maybe the 4 with the 6 or cancel the x squared with the x squared, but you cannot just cancel one part of a term, especially if that term is added or subtracted to or from another term. So what you need to do is factor that numerator. Whenever you factor, you have to look for a greatest common factor, and you can pull a 4 out of all of those terms in the numerator. If you pull a 4 out, in parentheses you'll have x squared plus 2x minus 15. We'll come back to that trinomial because that'll factor. But in the denominator, let's pull a 6 out of those two terms. So in parentheses I'll have x squared minus 9. Back up in the numerator, I have that trinomial's lead coefficient 1, so when we factor it, it'll factor to two binomials, two factors of negative 15 that add up to positive 2. One will be positive, one will be negative. We need to have the 5 positive, the 3 negative, so that they add up to a positive 2. In the denominator, I've got a difference of squares. X squared minus 9 will factor to x plus 3, and x minus 3. Now, once you've completely factored the numerator and the denominator, now is when you can cancel things top and bottom. You can only cancel things that are multiplied together. So this whole binomial, x minus 3, there's one on top and one on the bottom, so we're going to cancel them. The only other thing we can cancel is look at the 4 and the 6. They have a common factor of 2. If I factor 2 out of 4, or cancel, I'll have 2 left. And if I cancel 2 out of 6, I'll have 3 left. When you're simplifying rational expressions, you're going to be crossing out a lot of stuff top and bottom. So you need to be aware of what's left over. In my numerator, I had a 2 and a factor of x plus 5. In the denominator, I've got a 3 and a factor of x plus 3. You want to leave your answer factored in factored form, just like that.